Forests act as the world's oxygen factory, tirelessly converting carbon dioxide into the oxygen we breathe. They also serve as a global bank to store the CO2 in the air. Alone, General Sherman, the world's largest tree, in its remarkable lifespan of 2,400 years, this solitary giant will store 1,400 tons of CO2, embodying the extraordinary capacity of a single tree to impact the global carbon cycle. However, despite the critical role of trees, deforestation is occurring at an alarming rate. United Nations estimates reveal that over 10 million hectares of forest are lost annually. To put this into perspective, it's equivalent to clearing an area the size of 27 football fields every single minute. Chaining is the worst form of tree cutting practice. It involves a massive anchor chain, often over 20,000 pounds, stretched between two large bulldozers to uproot trees completely, taking their roots along. With each pass, hundreds of trees are flattened. They not only uproot and kill trees, but also obliterate the underbrush, the nesting grounds, and the intricate network of life that calls these forests home. So this process is more than just felling trees. It wreaks havoc on the entire forest ecosystem. It devastates the soil, sagebrush, grasses, and forbs, and in fact, in a single sweep, chaining can decimate habitats for countless species, both flora and fauna, erasing years of natural growth and biodiversity. In the US, the Bureau of Land Management has been criticized for such practices on public land in the name of vegetation removal. Back in 2019, a report published by Wild Utah Project, a nonprofit organization, highlighted how vegetation removal will further destroy the ecosystem of Hamlin Valley. According to this report, windstorms carry away desert soil from the Colorado Plateau. This soil then gets dropped on the snow in the Rocky Mountains. Nowadays, because of activities such as clearing vegetation, grazing, using off-road vehicles, and extracting resources, there's about 5 times more dust settling on these areas. When this dust covers the snow, it absorbs more sunlight, similar to how a dark t-shirt gets hot in the sun. Enhanced solar radiation accelerates and advances the snow melt. Analysis of data from 2005 to 2008 reveals that such dust layers on the snowpack decreased the Colorado River's flow by approximately 5%, equating to about 750,000 acre-feet. This volume is nearly double the annual water consumption of Denver. This is the tip of the iceberg. On a broader scale, forests are rapidly being cleared to create more farmland. With the global population on the rise, there's an increasing demand for land to boost food production. Out of the total land available, more than 36% is being used for agriculture, which is reducing in direction from urban areas and expanding towards forest. The challenge here is that crops, unlike forest trees, lack the ability to absorb significant amounts of CO2 for prolonged periods of time. Also, the use of fertilizers, livestock farming, and energy consumption make the agriculture sector one of the largest GHG emitters. According to the Food and Agriculture Organization, FAO, 34% of the total global emissions come from agricultural practices. Although no one can win the fight against climate change, agriculture feeds more than 8 billion people on the earth. This complexity leads to a heated debate among people, politicians, and even the global north and the global south. One fancy claim that came up as a solution to this problem was vertical farming. Some companies claim that they can produce 400 times more yield compared to conventional field farming methods. Moreover, this method also saves 95% of water by recycling it. Another benefit of vertical farming is that pesticides aren't used since plants are grown in a controlled environment. All these benefits of vertical farming are not going to be beneficial for the environment unless they use clean energy from renewable sources. In these indoor farms, LED lights and air conditioners use a tremendous amount of power. To some estimates, around 5 acres of land are required for solar panels to power a vertical farm for only 1 acre equivalent food in conventional farming. In that case, vertical farming is not at all a sustainable solution. A sustainable method is a practice that meets current needs without jeopardizing future generations' ability to meet theirs. It balances environmental health, economic viability, and social equity often involving renewable energy, resource conservation, and eco-friendly practices, ensuring long-term ecological stability and human well-being. A sustainable answer to deforestation is agroforestry. It's a versatile land use management system that ingeniously combines agriculture with forestry, serving as a dual tool for fulfilling food requirements and preserving forest lands. This approach integrates trees and shrubs into farmland and pastoral areas, creating a symbiotic ecosystem that enhances biodiversity and ecosystem services. By growing trees alongside crops and livestock, agroforestry systems produce a diverse array of food products, such as fruits, nuts, grains, and dairy, contributing significantly to food security. The presence of trees in these systems plays a critical role in maintaining soil health, preventing erosion, and enhancing water retention, which are vital for sustainable agriculture. Simultaneously, these trees emulate natural forest conditions, supporting various wildlife species and conserving biodiversity. Furthermore, by increasing the productivity of existing agricultural lands, agroforestry reduces the pressure to clear additional forest areas for farming, thereby helping to preserve forest lands. This strategic blending of forestry and agriculture not only optimizes land use, but also offers a resilient response to the challenges of climate change and environmental degradation. But agriculture is not only causing deforestation. A direct threat to forests comes from the timber industry. Illegal logging presents a major challenge for governments due to its complex nature and far-reaching impacts. It often involves organized crime networks, making enforcement difficult. This illicit activity not only leads to environmental degradation, including deforestation and biodiversity loss, but also undermines legal trade and sustainable forest management practices. Furthermore, beyond illegal activities, the challenge lies in addressing the dependence of many legitimate businesses on timber for consumer products. So, who should be blamed when the end product of forest trees is heavily purchased and used by common people? Whether you buy grocery items in a paper bag, order pizza in some sort of paper box, or unbox a new device, the byproduct of trees is everywhere. Over the past 4 decades, paper consumption has skyrocketed by 400%. This surge in usage has led to the daily felling of over 2 million trees worldwide, amounting to 4 billion trees annually to fulfill our paper demands. A pine tree with a trunk length of 45 feet and an 8-inch diameter can be used to generate about 10,000 sheets of paper. Roughly 55% of the manufactured paper is used for packaging purposes. Another 26% is used just for printing and writing. This is just the beginning. At every stage of paper production, carbon emissions occur, which contribute to more global warming and further deforestation. In an attempt to lessen the negative effects brought by these greenhouse gases, the Greenhouse Gas Protocol has developed an internationally recognized standard for greenhouse gas accounting based on 3 scopes. First scope, this includes the emissions from activities and sources that are owned and controlled by the company. These are the emissions created by the operations within a certain company. Second scope, the second scope already includes the GHGs produced when electricity is consumed. It's important to note that the user is accountable for these emissions, and second scope emissions can be reduced by lowering one's electrical consumption or choosing more sustainable sources. Third scope. This is the largest scope because it includes all indirect emissions from sources not owned or controlled by the company. This includes the emissions produced during the production of goods or services, the transportation of products, and employee commuting. To give you a thorough understanding of this, let's delve into the process of paper production. It starts with planning to harvest trees. Foresters assess the forest and identify which trees are to be cut. This decision is based on various factors, such as the age, health, and species of the trees, and the goal is often to remove the trees that are mature, overcrowded, or diseased, thereby promoting the growth of the remaining trees and overall forest health. Harvest planning also involves evaluating the best possible route to cause minimal environmental impact. All the calculated data is then fed to the forestry machine in the form of map data. This helps operators cut down the selected trees. The machine's usual design consists of a platform fixed to a tractor with a revolving boom supporting a cutting head that can be fitted with one or more shears or saws. The cutting head circles around the tree trunk to chop it down effectively, and this method lowers the manual requirements and increases efficiency by enabling loggers to fell multiple trees at once. Also, it is common practice in this field that stumps are cut to a length of 1.3 meters. High stumps, also termed artificial snags, are intentionally left in place to create dead wood habitats for dependent species, playing a crucial role in preserving biodiversity in forests. Research indicates a notable increase in beetle populations, including those at risk, in these dead wood areas following clear cutting. The existence of high stumps can cause an immediate 50% rise in species numbers post-felling, with this positive impact enduring for up to 3 years. These stumps serve as essential refuges, enabling various species to withstand the disturbance of logging and aiding in the gradual recovery of the forest's ecosystem. After that, the harvested trees are loaded onto trucks to be transferred to the processing facilities. Once the logs reach the facility, they will be loaded onto this timber machine for further processing. After that, the logs will be washed to ensure that no debris or unwanted particles get in the way. The thawing also helps soften up the logs for easier processing. After that, logs will be fed into a debarking machine to get rid of all their bark. These are the parts not used in paper production. To minimize waste, the removed barks are used as biofuel that can power a factory or be sold to power generating companies. When all that is left are logs, they'll be put through a stone trap metal detector. The screens of this machine help get rid of any stones or metal objects. Not removing these thoroughly can cause a lot of issues for the whole process. After being cleaned, the logs are fed into a chipper, which is a massive spinning disc plate with incredibly sharp knives on it. The chipper cuts the logs at an amazing speed of 1.3 meters per second, which creates tiny wood chips. Typically, they are 22 millimeters in width, 22 millimeters in height, and 5 to 6 millimeters in thickness. The chips must be the same size to make sure that the process runs smoothly. Then the chips will be fed to this screw conveyor. This is the main machine that will help in transporting the wood chips from one point of the facility to another. The chips will be divided into different fractions: the fine fraction, the lower mid-size fraction, and the upper mid-size fraction. They will all be placed separately in this one facility. When all that is done, they will be placed onto a belt conveyor that will transport them again to the next spot. This time, the transportation will be for storage. The wood chips will be stored inside a silo, which is a safe and efficient way to store large quantities of material. Silos also help prevent spoilage and damage to these wood chips. The next part of the process is transforming chips into pulps. The chips will be transported from the storage silos to another processing area. They need to be transferred to a TMP, or thermomechanical pulping plot. Then the process of entering the chips into a steam bin will begin. They're exposed to hot steam, which heats the wood. The purpose of this process is to even out the moisture content in the chips. The potato chips are taken to a chip washer, where any leftover stones, twigs, and other debris are meticulously removed after they've been sorted and cleaned. The premium chips rise to the top of the vat on their own, and are then gently pushed into a pumping bin by a paddle wheel. After that, the chips are transported by water to dewatering screws, which take them out of the water and remove any extra moisture. The lining that holds wood fibers together is softened during the refining process by heating the fibers with steam. After that, the chips are mechanically separated in 2 stages. They are fed into a high-pressure gap that separates them between a revolving disc and a static disc. As it rotates at a speed of about 1500 RPM, the chips are forced through grooves. The heat and pressure cause the water in the wood chips to evaporate, and a screw directs the fibers into a second plug screw feeder for the second refining stage, while steam is collected at the cyclone's top. Then the pulp will be transferred to the second stage of refining. It will then be screened to make sure that no fibers are left. To minimize waste, the screened and rejected fibers will be placed in a reject refinement for further processing. On the other hand, the screened and accepted pulp is stored in a storage silo again. The extraction of linen from the fibers occurs through a computer-controlled process that involves cooking the bagasse with water, steam, and caustic soda. This method allows for the automated addition of ingredients and results in the removal of impurities such as leftover caustic soda and linen that have dissolved. To achieve a white paper product, there are 3 stages of bleaching involving chlorine dioxide, hydrogen peroxide, and sodium hydrogen solution. These steps remove most of the remaining linen, leaving the fibers pure and white. Finally, an additional treatment with hydrogen peroxide ensures the highest quality and whiteness of the final product. To make sure that the bleaching chemicals are all removed, the pulp will undergo another cycle of washing. It will also be de-watered twice to ensure quality. After that, the pulp will be sent to a silo for storage purposes. The paper machine spreads out water-mixed fibers in a thin layer using a mesh screen. After removing the water one step at a time, the finished sheet has only 7% water and 93% fiber. Through this process, the starting stock mixture becomes 93% fiber and 7% water. After that, the process will continue with the head box and wire section. This is where the pulp will mass and be squirted through a horizontal slit. Then it will be moved over a moving wire mesh to remove excess water. Subsequently, the fibers will be spread out into thin sheets. These thin sheets will be fed into a pressing machine to squeeze up about 50% of the moisture left in the fibers. The water gathered in this and the previous steps is also recycled to reduce waste. Now, paper is dry and thin, right? This is why these thin sheets still need to undergo a drying process. They'll be subjected to 100-degree heating via these cast iron cylinders. In another processing plant, they also add a film of chemicals to improve the quality and property of the paper. The process of calendaring, which is carried out at the conclusion of the paper machine, involves pressing the paper against a softer backing roll with a hard heated metal surface to create a smooth, glossy sheet while maintaining a uniform thickness. It's similar to ironing a garment on an ironing board, but it happens on a far bigger scale. The advanced QCS system performs quality scanning. It has a state-of-the-art monitor that oscillates over the sheet to measure a variety of crucial paper characteristics. These include thickness, brightness or whiteness, weight in grams per square meter, and the inclusion of mineral fillers. We make sure that all these elements satisfy the specifications in every direction on the sheet by utilizing modern data analytics, which produces a uniform and superior printing surface and texture. Once all of that is done, the paper will be wound on the jumbo reel. Typically, this will weigh about 40 tons of paper. Then, it will be slit into smaller rolls to facilitate easier delivery. It would be foolish to stop paper production. Those who are using paper will start using plastic products instead. So, in such scenarios, the best option is recycling. Estimately 24 trees are required to make just 1 ton of standard office paper. By recycling, 17 of them can be saved. Also, when paper breaks down, it releases methane, which causes global warming. Recycling them keeps their methane locked up for a longer time. There are 3 categories of paper that can be used as feedstocks for making recycled paper: mill-broken, pre-consumer waste, and post-consumer waste. Their process starts by measuring the weight of any truck that comes inside through a scale. Once that is done, they'll be directed to the building where they can load and unload. Since this part involves materials that are prone to producing dust, they also have a machine that helps them manage that. The first conveyor of this process will be directed to the pre-sort line. This is where workers will separate the contaminants from the actual needed materials. As the cardboard screen rises, the materials fall onto the disc. The excess material from the previous steps will be released onto the floor for manual loading onto the baler line. After passing through the cardboard screen, the remaining material undergoes an additional 2 quality control checks before being conveyed into the trommel. Meanwhile, any materials that fail to pass through the disc screen are directed straight to the trommel. The purpose of the trommel is to separate the material into 3 streams. There are the finer ones, the medium ones, which are 10 inches in diameter, and the larger ones that exceed the previous measurement. The finer ones will be the first to drop out. Then, it will be passed onto a conveyor belt again. This conveyor belt directs the material to a cross-belt magnet. This functions as the material that captures ferrous materials. Then, an eddy is used to capture aluminum in the materials. Ideally, this is also the part where the large-sized materials come out of the trommel. Since they're already separated, the large materials will be transferred to a blower sorter. What does it do? Well, this sorter is designed to separate the light materials from the heavy ones. Then it creates a stream for each of them. These streams are then directed to a sorting line where the remaining contaminants are then also removed. The light materials are then conveyed to the mix paper truck, while the heavy ones are moved to the optical sorter. Now for the medium-sized materials, they'll go directly to the ballistic sorter. The purpose of this sorter is to separate the two-dimensional materials from the three-dimensional materials. When it comes to the two-dimensional materials, they need to pass through an optical sorter with the cleaned stream. This will result in mixed papers. On the other hand, the three-dimensional material is conveyed to the optical sorter. In the optical sorting system, the mixed materials enter and are split into separate lines for high-density polyethylene, HDPE, polyethylene terephthalate, PET, and cartons. Each line has its own inline optical sorter that captures the specific type of material. After passing through these sorters, the materials go through additional magnetic separators to catch any stray aluminum. After that, the materials will be processed thoroughly through a paper mill. This is where they'll be laid into a thin sheet and pressed down to produce paper. Paper mills use wood pulp or recycled fibers to make paper products like tissue, printing, and packaging paper. Newspaper, mixed paper, and old corrugated cardboard are examples of recycled materials used to make duplex and triplex boards. To make a homogeneous blend, the waste paper is cleaned, pulped, and combined with virgin paper pulp. A 4-dryer machine is used to shape this slurry into sheets. After that, the sheets are finished, dried, and pressed like regular boards. Through this method, less energy is used, fewer greenhouse gas emissions are produced, and less virgin wood fiber is needed. The environmental effect of many boards is further decreased by the use of certified post-consumer recycled content in their production. For forestry seedlings to thrive and survive, special attention is needed. The first step is selecting native tree species that are appropriate for the soil and climate in the area. Young trees will grow faster and more adaptively thanks to this option. Next, before seeding, it's critical to maximize seed quality. High germination rates in fresh seeds improve the likelihood of a successful sprout. To assess the quality of seeds, tests for viability and purity can be carried out in lab settings or in field settings. It's crucial to prepare a seed bed that drains properly. A specially blended soil blend guarantees healthy root growth right from the beginning. After removing any trash, weeds, pebbles, etc., prepare the seed bed. Plant the seeds at the ideal depth for germination, which is typically double their length. A proper depth minimizes seed mortality from damping off or overheating while promoting healthy root development. It's also crucial to maintain consistent moisture levels in the initial weeks following seeding. Mulching around recently planted seedlings inhibits weed growth and helps conserve moisture. To preserve the health and production of your forestry seedlings, you must observe them on a regular basis. Regularly check them for indications of pests, illnesses, nutrient shortages, or other problems that could affect young trees. Prompt remedial action is made possible by early discovery. When seedlings are 5 to 10 centimeters tall, move them into separate containers or the nursery bed itself. Before transplanting, hardening seedlings helps them become more accustomed to the outside. Gradual exposure to sunlight and wind minimizes shock. In due time, these seedlings will grow into mature trees that will soon be harvested and cut down too. But did you know that when you cut down one tree, you need to plant 3 more spruces? Maintaining healthy forests, combating climate change, and preserving wildlife habitats can all be achieved by planting 3 spruce trees for every one that is cut. It guarantees long-term sustainability, enhanced biodiversity, ongoing regrowth, soil erosion control, carbon sequestration, and improved timber quality. In addition to that, it takes a lot of years before a tree grows into its mature state too. In fact, it typically takes around 10 to 20 years for a spruce tree to reach its full height. This is why a tree harvester can only experience at least 1 tree harvesting season in their whole lifetime. Speaking of forestry, one of the problems faced in this field is forest fires. In the last 10 years, this has destroyed around 82 million hectares of forests around the world. One of the reasons these forest fires are hard to eliminate is the burning of stones. Burning stones are materials that can survive high temperatures without melting or catching fire. They're frequently referred to as fireproofing or heat-resistant rocks. These stones are frequently used to build fire breaks, which are gaps made of non-combustible material used to contain wildfires. Burning stones are removed from forests to stop wildfires from spreading and save the surrounding region from harm. Our forests provide a lot of benefits to our society. They are home to 80% of the world's terrestrial species of animals, plants, and insects. Forests are also one of the main reservoirs of carbon and a source of much-needed oxygen. The calls to protect our forests and end global warming are all valid and should be listened to. However, it's important to remember that things are not always black and white. A lot of factors contribute to global warming, and deforestation is just one of them. In his book, How to Avoid a Climate Disaster, Bill Gates explained how growing forests on all of the surface of the Earth still will not save us from global warming. Instead, we should embrace innovation and work with it hand in hand to protect what little we have left of Mother Nature.